Polynomials. This is the third chapter in the state syllabus. This is one of the important chapter in 10th class in state board syllabus. Now we are going to discuss about this chapter polynomials. First of all, I am going to tell definition of the polynomial. A polynomial in X is an expression containing the sum of a finite number of terms of the form ax power n for any real number a, where n is a whole number. N is a whole number and a not equals to 0. This is the definition of the polynomials. A polynomial in X, for example, x square minus 4x plus 3. A polynomial in X, yes, it is in variable X, is an expression containing the sum of the finite numbers. Yes, these are finite numbers only. We can count how many terms are there. 1, 2, 3. Countable terms only. That's why finite numbers. Sum of a finite numbers. Yes, here 3 numbers are there. So x square plus minus 4x plus 3. Nothing but x square minus 4x plus 3. So sum of a finite number of terms of the form ax power n. Here n is a whole number and a is a real number. Here what is a? Coefficient of x power n. Coefficient of x power n. It must be a real number. It must be a real number. Yes, minus 4 is a real number. Coefficient of x square 1 is a real number. Constant term 3 is a real number. And n is a whole number. Yes, now we are going to check n is a whole number or not. Here x square is there. 2. X power 2. 2 is a whole number. Yes. Here x power not there means 1. 1 also whole number. 3 is nothing but 3x power 0. 3x power 0 means here 0. X power 0. 0 also a whole number. So this condition has to satisfy. So this type of algebraic expressions are called polynomials. All the algebraic expressions are not polynomials, but all the polynomials are algebraic expressions. Okay, this point should remember. For example, one more example, x square minus 5x plus 1. This one also one polynomial. X plus 1 is also a polynomial. X cube minus 2x square plus x plus 5. This one also a polynomial. These are satisfying the given conditions. Ax power n is a whole number and a is a real number, a not equals to 0. Yes, here coefficient of x square not equals to 0, coefficient of x not equals to 0, coefficient of x cube not equals to 0. Condition satisfied. So this type of all the algebraic expressions are called polynomials. All the polynomials are algebraic expressions, but all the algebraic expressions are not polynomials. Now we are going to see which are polynomials, which are not polynomials. So we are going to take some examples. Okay, I am writing here. First one, 2x cube. Is this polynomial? Yes. 2 is a real number, n is a whole number, and coefficient of x cube not equals to 0. Yes, it is satisfied. It is a polynomial. Yes, it is a polynomial. There is no doubt. Next, second example is 1 by x minus 1. 1 by x minus 1. Is this a polynomial? No, it is not a polynomial. Why? It is not polynomial. Why it is not polynomial? So here the variable is in denominator. If you write in numerator, it will change as like this: x power minus 1 minus 1. X power minus 1, here power minus 1 is there. Minus 1, it is not whole number. In the definition I said whole number. N must be whole number. Whole number means we know very clearly 0, 1, 2, 3, 4, 5, 6, all the positive numbers one including 0. So here negative integer is there. That's why it is not a polynomial. Next, third one, 4z square plus 1 by 7. Is this polynomial? Yes, it is 100% polynomial only. No doubt at all. Here z square is there, variable z here. Especially we have to check what is the power of the variable. If it is negative integer, it is a not polynomial. If it is a positive integer including 0, that is a polynomial. This one point should check. You can understand very easily. Next, fourth one, m square minus root 2m plus 2. Is this polynomial? Yes, this is a polynomial only. Here coefficient of m, irrational number is there. Even the no problem. Irrational number also a real number. Here already we written real number a. A is a real number. A is a real number. Yes, root 2. Root 2 is an irrational number. Irrational number also real number. Rational numbers also real numbers only. So it is a polynomial. Next, fifth one, p power minus 2 plus 1. P power minus 2 plus 1. Is this a polynomial? No, it is not a polynomial. Why it is not polynomial? See here variable p. P power how much is there? Minus 2. Minus 2 is negative integer. If it is a negative integer, it is not a polynomial according to definition. That's why it is a not a polynomial. Okay. Next concept, degree of the polynomial. Degree of the polynomial. First of all, definition. I am going to write a definition. Definition of the degree of the polynomial. If p of x is a polynomial, if p of x is a polynomial in x, the highest power of x, the highest power of x in p of x, is called degree of the polynomial. Degree of the polynomial. degree of the polynomial. Okay. Now degree of the polynomials, two types we can see. One is degree of the polynomial. Degree of polynomial we can see two types, children. One is one variable. Second one is for each term. Add exponents of each variable term, each variable in it. Okay, so one variable examples we will see some. First example is 6x power 5 plus 2x square minus 7x plus 9. This is a polynomial. Its degree now we are going to write. Here written the definition is p of x is a polynomial. Highest power of x in p of x. Highest power of the variable. Here variable x, no. What is the highest power of the x? That is the degree of the polynomial. In each term now we are going to check. Here x power 5. Here 5 is there. Here x power 2 is there. Here x power not there means 1 is there. Here 9 is nothing but 9x power 0. So constant term degree is 0. 0, 1, 2, 5. What is the greatest value among them? 5 is the greatest value. That's why its degree is 5. That's it. Now one more example we are going to take. 21x plus 6x cube plus 7 plus x square. This is one of the polynomial. Now we are going to write its degree. Degree equals to, see here x power not there means 1. Here 3 is there. Here this is constant term, no? 0. Here 2 is there. 1, 3, 0, 2. Among these four values, what is the greatest value? 3. So 3 is the degree of this polynomial. So degree equals to 3. Highest power of the variable in p of x is called degree of the polynomial. So in this polynomial, highest power of the variable is 3. That's why degree equals to 3. Now in this section we are going to take one example. 5xy cube plus 27xy plus 9y square plus 9. So this is the one expression. Now we are going to write its degree. So how to write this degree, do you know? Here we are seeing two variables. This section, in one variable section, very easy to write, but here two variables are there. To write its degree, you may feel somewhat difficult. Not difficult, just you try to understand. So we have to add. In this first term, xy is there. X power not there means 1. Y power 3 already is there. 1 plus 3 equals to 4. Right. First term clear. Second term. Xy is there. X power 1, Y power 1. 1 plus 1 equals to 2. So this one 2. 9y square. This one also 2. Here constant term is there. This is the 0. 4, 2, 2, 0. What is the maximum value? 4. 4 is the maximum value. So its degree is 4. Its degree equals to 4. Next one more example. Second one. 7xz plus 10 plus 3z cube y plus 19 y power 7. Here each term, what is the degree? We are going to check. 7xz. X power not there means 1, z power not there means 1. 1 plus 1 equals to 2. Okay. This is constant term 0. Here z power 3, y power not there means 1. 3 plus 1 equals to 4. Plus 19 y power 7. So here variable y, its power is 7. So its degree is 7. So finally we got to 2, 0, 4, 7. Among these four values, what is the maximum value? 7. So its degree is 7. Okay, so how to find the degree of the polynomial we discussed. According to degree types of polynomials. According to degree types of polynomials. The first one is linear polynomial. The first one is linear polynomial. A polynomial of degree 1 is called a linear polynomial. Is called a linear polynomial. Its general form, general or standard form. Standard form is ax plus b. For example, x plus 3 is a linear polynomial. Its degree is 1. Next 2x plus 1. Next x minus 1. 3x minus 4. These all are linear polynomials. Why? Because its degree is 1. Its degree also 1. Its degree also 1. Its degree also 1. So degree 1 polynomials are called linear polynomials. Its general form or standard form is ax plus b. This also should remember. Next, the second one is quadratic polynomials. Quadratic polynomials. Quadratic polynomial. Quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. Is called a quadratic polynomial. Is called a quadratic polynomial. Its general form or standard form. Its general form or standard form is ax square plus bx plus c a not equals to 0. Here also a not equals to 0. For example, first one 2x square plus 3x plus 2. This is a quadratic polynomial. Here coefficient of x square not equals to 0. The second one is x square minus 2. This one also quadratic polynomial only. Next one x square. Next fourth one x square minus 3x minus 12. Like this we can write a number of examples. These all are the quadratic polynomials only. Next third one cubic polynomial. Cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. A cubic polynomial. Its general form, its general or standard form is ax cube plus bx square plus cx plus d. Here a not equals to 0. Example, first one, x cube. X cube also one of the cubic polynomial only. Second one, x cube minus x, cubic polynomial only. Next, third one, x cube minus x square plus x plus 1. Next, fourth one also one example, 2x cube minus x. These all are the cubic polynomials only. Why? Because their degree is 3. Its degree is 3. That's why cubic polynomial. Its degree is 3. Its degree is 3. Its degree is 3. That's why these are called cubic polynomials. Its general form is ax cube plus bx square plus cx plus d. A not equals to 0. Here a comma b comma c comma d belongs to or capital R means real numbers. A b c d are real numbers. Okay, next one, biquadratic polynomials. Biquadratic polynomials. Biquadratic polynomials. Biquadratic polynomial. A polynomial of degree 4 is called biquadratic polynomials. Biquadratic polynomials. Biquadratic polynomial or fourth degree polynomial. Fourth degree polynomial. Okay. Its general form is general form or standard form. Standard form is ax power 4 plus bx cube plus cx square plus dx plus e. A not equals to 0. A comma b comma c comma d comma e are real numbers. Real numbers. For example, first one is 2x power 4 plus 9x cube plus x square plus 2x plus 1. Its degree is 4. That's why it is called fourth degree polynomial. The second one is x power 4 minus x cube plus x square plus 2x plus 5. Its degree also 4. That's why it is called